Welcome back. In this video, we're going to be talking about applications of the combinations that we saw in the previous video. The first application has to do with counting subsets of a larger set. In each of the applications, you'll see the same argument being used over and over again. So let's remind ourselves what n choose k is. N choose k is the number of ways to choose k objects out of n total objects. And remember, the k objects that we're choosing are not ordered. Our first question is, how many subsets of a set S that has n elements are there that have k elements? We might call these k subsets of S to reinforce that they are subsets of S that have k elements. A good thing to do with this type of question is to try an example. Let's consider this set S, the set containing A, B, C, D, E, and let's let k be equal to 2. So we're looking for two subsets of S, or subsets of A, B, C, D, E that contain two elements. Let's write them down carefully. Well, we could choose A and B, or we could choose A and C, or we could choose A and D, or we could choose A and E, and that's all the two subsets that include A. Then we could have B and C, or B and D, or B and E. And now we've covered all of the subsets that include A or B. Then we could have C and D, or C and E. And there's one more, the subset that contains D and E. So what we've just figured out is that there are 10 two subsets of the set A, B, C, D, E. Now let's put this in the framework of combinations. We can see that a subset of S with k elements corresponds to choosing k of the n elements of the set. The way we wrote down all the two subsets of S was to find all ways in which we could choose two elements out of the 5. And when we're choosing k elements out of n, the number of ways to do that is exactly n choose k. And we can quickly check that 5 choose 2 is equal to 5 factorial over 2 factorial times 3 factorial, which is equal to 5 times 4 times 3 times 2 times 1 over 2 times 1 times 3 times 2 times 1. The 3 times 2 times 1 divides out to 1, and we're left with 10. So we're getting the answer that we expect. The number of subsets of size 2 of a set of size 5 is going to be equal to 10.